So I'm hoping you've watched the introduction to the bisection method, and in this video we'll just talk about the algorithm of this method. So I started with an example to just help you understand the basic idea, why it's important and how it's helpful. So let's get to see how this one is going to work out. So I'll just remove that for the sake of the space. So the first thing that we'd want to do is, first of all, we want to make sure that the program doesn't learn continuously. We would want to have a maximum number of trials. So we say we need to have a maximum number of iterations, and then we need to have a tolerance for our result as well. So the first thing that we'd want to do first of all is, we have our tolerance, and then we also have the maximum number of iterations. So we'll just say n. So we shouldn't learn it more than n times. Okay, and then if we have a tolerance, if our value of our tolerance is less than the given value, then we can consider that to be our root of our question. So of course we do know that we are looking at this kind of a case where you have something like that, and the basic idea is, if you're trying to look at A and B, so if you try to find the midpoint, it may be roughly somewhere there, right? So if you find the midpoint R there, what do you expect? So the basic idea is you're working with these, the function of what? The function of A, the function of B, and then you'll be comparing that with a function of R. So whichever gives you a positive value, whenever you multiply the function of A and the function of B with the function of R, whichever gives you a positive value tells you that they're on the same side. So if you multiply the function of R, which is a positive in this case because the function is somewhere above the x-axis, even there is also above, so these guys are going to give you a positive value. What do you do in such a case? So since they're giving you a positive value, you discard A and you consider the midpoint, and then you try to look, your midpoint will now become your new value of what? Your A, and then you try to find the midpoint. So this time around the midpoint may be somewhere there, so you discard your B, so your R will now become your new B, and then you try to find the midpoint until you get closer and closer and closer to where the root is. That's what we're trying to do. So now I want to put that in terms of an algorithm, and there may be some cases, of course, where you will try to find the midpoint, and then you find that if you try to find the function of R itself, it will give you 0, like from our previous example in the first video. So when it gives you a 0, it implies that that's the root itself, because we know at the root the function is equal to 0. So that's what you need to keep in mind. Okay, so let's put this in terms of an algorithm. So the first thing that we'd want to say first of all is we have our tolerance inputted, and then we have a maximum number of iterations. So we'd want to, first of all, we initialize our value of I. So let our I be equal to a 1, and then we'll just consider 1. So the function of A, which I'll just say fa. So let our function of A be dependent on the value of A. So we're trying to find now the value of function of A. Okay, that value here. What happens? So we need to make sure that it doesn't learn continuously. So we'll say while. So let me just use a different class. So while our I is less than or equal to the maximum number of iterations. So while that is that, what are we going to say? So let our R be equal to what? So we'll try to find the midpoint. So the midpoint is A plus B over 2. So that is one way you can find the midpoint, but you'd want to put it in a way that you're trying to show, let's say a very good example may be the midpoint of 2 and 4, right? The midpoint of these guys is what? The midpoint is of course 2 plus 4 is 6, 3. So 3 is the midpoint. Yeah, did I have to count that? Yeah, so yeah, 3 is the number that lies between 2 and 4, right? So you don't want to say 2 plus 4 over 2. So you'd want to put it in a way where you can get to say my midpoint is 2 plus 1. That's what we want. Yeah, that's the midpoint is 2 plus 1. So how can we do that? So what we'll say is this. So our R can be equal to A and then plus just a difference. So the difference of the two is what? The difference is like 2 minus 4. The difference is a 2. So I have a 2, right? So we're subtracting the 2. And then since we said I can put it in the form of 2 plus 1. So I can just say like 4 minus 2 is 2 divided by 2 give me a 1. So this is the way we can express our midpoint. And that's what I'm going to do. So we'll be using this one because this value will be compared against the tolerance. If it's less than the tolerance, then your R can be considered to be the root of the given function. So our R is going to be A plus. So of course R is just a midpoint. Okay. So now what happens that after that? So you found the midpoint, R there. Of course, pay attention to the diagram because it will also help you to understand, right? So we found our value R there. So the first thing that we're going to assume is we assume the function of R is equal to 0. And if that's true, what are we trying to say? So first of all, we're trying to find the function of what? R using the determined or the calculated value of R there. So that's what we've done. And what has happened now? So we're trying to ask ourselves a question. Okay, is it equal to 0? So say if this guy, if fr, the function of R is what? If it's equal to 0, or if it's not equal to 0, or we'll say, I said this part is very important because we are comparing it against what? The tolerance. So I'll say if b minus a over 2 is less than the tolerance, what happens? So if b minus a over 2 is less than the tolerance, then we can consider R to be what? Our root. So we'll say if that's true, then we'll just output the value of R to be our root. So we'll just say output R. Okay. And then we can just stop. And then we'll stop. Okay. So that is the way you get to look at this algorithm. But we're not done. Because it's not always the case that this is going to be true. So while that may not be true, what do you get to do? So I'll draw back our diagram there, our diagram. So this is a case that we have. And then you have your A and your B. Now, since we've considered a function of A, so I'll consider midpoint to be somewhere there. So, since it has not worked, we've not yet found the value of R, what are we going to say? We need to consider new values that we're going to work with. So we'll say, if the product of your A, if a function of A multiply against a function of your R, if these guys, if you multiply with their functions, they give you a positive value. So that implies greater than 0, not so? If it's positive, then what are you trying to say? Then you're trying to say they're on the same side, and then you'd want to discard your A. And you can discard your A by rating the new value of A to be R. So your new value of A will be R. So you discard the A. Why are you trying to do that? You're trying to do that because you still want to go back to that stage where you can do everything else, right? You try to find the midpoint again from what I demonstrated. It's like if this one refuses, you consider this one and that one. Again, you find the value there, that one and this one, until you get closer and closer and closer. So we are discarding some values there, right? So we'll say, okay, our new value of A now will be what? If it's positive, then it implies they're on the same side. So we'll rate the new value of A be equal to R, right? And then we'll repeat the same procedure there. We'll find the midpoint, the new midpoint, and then try to find the value there again. Check this as well. Yeah, until we just get to a point where it makes sense, right? So, of course, that may not directly be true. So, if it's not true, let me just now move this algorithm on top. Okay, let me do this. Okay. So while it may not be true, what do we get to do? So we'll do this. If it's not true, then we'll say else. If this is not true, then it means that f of b by f of r is one that's going to be greater than 0, and in such a case we'll say, okay, let's just say new value of b be equal to r. Okay, so now what happens? So after you've done this, what we're trying to do is you're just going back to this case now. After you've done all that down, where you're going back is you're going back to that step. Okay, you're going back to that step. Now you're not going direct to that stage. The first thing that you're asking yourself is it less than or equal to n? Is it less than or equal to n? So if it is less than or equal to, you proceed and then find the midpoint. Now in a case where it is not, so I'll write something here. In a case where it is not, what are we supposed to do? Then the method has failed. So we'll just say, if it doesn't work out, then just say output what? Output method failed, or method failure. So that's the basic idea about the algorithm of the bisection method. And you notice that this is going to work for any values that you have. Okay, so of course before you get to substitute, as you come up with your flowchart there, you make sure every time before you get the while loop, you'd want to increase your value of what? Your I. But basically this is the way the algorithm comes out, and it summarizes everything that you get to do when you are working with the bisection method. So I hope you found this video helpful. Make sure you check out for the next one, where we get to talk about the flowchart. So thank you very much for watching, and have a lovely day.